Hello, this is Mr. Rasmussen with Algebra 2, Lesson 90, Systems of Three Equations. What do we do to solve when we got three variables? We've got an x, y, and a z, the three axes for a three-dimensional shape, and three equations there. Well, it's just several layers where we use elimination to keep canceling out until we have one variable left and we can get an answer. So looking at example 1, if you notice, if we look at just the first two equations, if we were to add these, the two y's cancel each other out. And you also notice that the two z's cancel each other out. The two z's cancel each other out if you add them, not the y's. So they actually take that separately and add those two together. So if we're to add a and b, we get 3x plus y is equal to 4, because the z's cancel out. Then you notice if you look at equation b and c and you add those together, those z's also cancel out. So let's add those. 2 plus 2 is 4x. Here is negative 3y, and then the z's are gone, and that will be equal to 1. So when you add those separately, then you get this, and what we've done is we've eliminated one of the variables. So now we just have 2 left, and we want to eliminate one of those. So if we notice here, if we multiply the whole top by 3, then my y's would cancel. So I'd get 9x plus 4, which is 13x. My y's would cancel, and then this would be 12, or equal to 13. So I divide both sides by 13, and my x value is 1. I got one answer. Okay, then what I would do is come back and plug that in to get a value. So if I take my equation here, let's rewrite it. 3x plus y equals 4, which is a true equation, correct? If I plug that value in for x right here, then I get 3 plus y equals 4. So let's subtract 3 from both sides. Y now is also equal to 1. Then now that I have two of those, then I come back to my initial equations and I need to find out what z is. So let's pick one. I'm going to pick this top one here. So it looks like my x value is 1 plus 2 times 1 plus z is equal to 4. So 1 plus 1 times 2 is 2. So that'd be 3 plus z equals 4. So subtract a 3, subtract a 3. Z is also equal to 1 for my first example problem. To unlock it though, that first thing is where you take the first two equations and cancel one of them, and then the second two and cancel one of them. All right, I want to look at the second example, and I've already written it out that way. Here's my equation a and b, and looking at this though, if I add these, nothing cancels, so I got to change something first to get something to cancel. We're going to multiply the top by 2, and if I do that, then it looks like my y's are going to cancel. So I get a 4x, and if I add that, I get 5x. I get a negative 2 and a positive 2. That actually cancels. My 2 times 3 gives me 6z, 1z, so plus is 7, plus 7z. And then that's equal to 2 times 9, which is 18, and then I add that to my 8. It looks like I get 26 here. All right, so what that did for me is it canceled the y. So I want my y's to cancel over here. That actually is set up already over here. So let's add those together. I get 2x, my y's cancel, plus 2z is equal to 8. All right, so then I take those and pile those on top of each other. So I'm going to write that over here. So 2x plus 2z is equal to 8. All right, nothing's going to cancel with each other, so I actually got to change the top and the bottom to get this to happen. So I'm going to multiply the top by 2 and multiply the bottom by negative 5. All right, I'm going to rewrite that just for simplicity's sake. So rewriting that, 2 times 5, 10x, 2 times 7 is 14z, equals 26 times 2, which is 52. Negative 10x, my negative 5 times 2 is negative 10z, is equal to a negative 40 there. All right, so wrote that one there and that one there, multiplying it out. Now when I add them together, my x's cancel. I get 4z is equal to 12 divided by 4 divided by 4. It looks like z is equal to 3. All right, so I got an answer for this problem here, the first one. Z is equal to 3. Now, pretty simple. I can just take that and put that right back into one of these equations. Let's take that one, 2x plus 2. Let's put it right back in there and solve for x to find out my x value. So 6, subtract a 6 from both sides. 2x is equal to 2, divide by 2, divide by 2. All right, my x value is equal to 1. I've got another answer. Okay, now I just need to find y. So let's go back and pick one of my initial equations and plug in some values. Let's grab this one right here, the one in the middle. So x is 1 plus 2 times y, don't know what y is, plus z, z is 3, is equal to 8. Right, so I grabbed my b equation there and then plugged in my x value and my z value. So combine like terms, the 1 and the 3 can combine to be 4, and then subtract 4 from both sides. So I get 2y is equal to 4. Divide by 2, divide by 2. My y is equal to 2. All right, if I were to write that out as a coordinate pair, my x value comes first, which is number 1, comma, my y value comes next, number 2, and then my z value comes last, number 3. It would be written that way in parentheses to indicate an ordered pair, or ordered triple rather, because there's 3 of them. Okay, that is that. Let's look at the practice problem. I'm actually not going to do the practice problem because the answer to the practice problem comes out into fractions. If you'd like to do the practice problem, feel free. I'll give you the answer after I do a different one. I'm going to do the problem from the homework. That's the odd one. I'm going to do number 7. And number 7 has 2x minus y. This is number 7 in the homework. Plus z. And I'm doing this one because the answer comes out to whole numbers and not fractions. All right, 2x minus z, or minus y plus z equals 2. Then we get x minus 2y, x plus 2y plus 2z is equal to 3 as my first 2 equations. And I'm going to rewrite that one and use that one with my third equation and see what we can get to cancel here to get this started. All right, so there's my equation A and B, and then my B and C. All right, looking at the first one here, it looks like if I multiply the top by 2, I get my y's to cancel. So I'll multiply my top by 2, and so that gives me 4x plus 1, 5x here. My y's cancel, plus 4z is equal to, this would be 4, that'd be equal to 7. Okay, over here, my y's also cancel without changing anything. So if I add those, I get 3x plus 3z is equal to 3. All right, let's bring that one over and line it up with my first set. All right, nothing cancels if I add it as is. What else can we do with this? How about, well, we're going to have to change, both of them. Let's change a -3 here and a +4 here. So let's rewrite that. That's -15x, 12x. That's going to give me a -12z here, +12z here. That's what I was canceling. And -21 and then a 12. So if I add those, it looks like I get -3x is equal to a -9. Divide by -3, divide by -3, x is equal to 3. I've got my first answer. Let's plug that back into one of these simple equations here. So I'll use this one here. 3 times 3 plus 3z equals 3. So 9, subtract 9 from both sides, plus 3z is equal to negative 6. Divide by 3, divide by 3. Looks like my z value is equal to negative 2. Double check that with my answer sheet here. All right, that is correct. Now I just need to find y. Let's go back to one of my initial equations. I think I like this one right here, the b equation. So let's write that out. We'll go 3 for x plus 2y plus 2 times a negative 2 for my z value is equal to 3. All right, so we get a negative 4 here. My 3 plus a negative 4 gives me a negative 1. And so I add 1 to both sides. 2y is equal to 4. Divide by 2, divide by 2. It looks like y is equal to 2. And double check that. And that is correct. So as an ordered triple, I get 3, 2, negative 2 as an answer. All right, if you'd like to do the practice problem, the answers to the practice problem are fractions. The answer is 8 over 3, 5 over 3, 4 over 3 as the x, the y, and the z value for the practice problem if you wanted to try that for an extra challenge there with fractions. Okay, hope that makes sense. And if you have any questions as you work through that, please feel free to contact me. Have a great day.